that was the drawing that you were given. And then they told you that you must use the last 3 digits of your student number for the missing dimensions there and there. So basically you would have added, let's say for argument's sake, your last 3 digits was 1, 2, 3. You would have added under 1, 2, 3 millimeters there and 1, 2, 3 millimeters down there for both the length and the breadth. Okay. And over and above, you should have actually added, if you look at the dimensions, the dimensions are based on that, from there to there, and from that point to that point. So you should have added actually 230, 230 on either side, right? But I see a lot of you added 220, which I overlooked it this time. But in future, if you add, you need to add. Don't forget, because you have to add the mortar. It's the brick is 220, but you get 10 millimeter mortar. You have to add that as well, because you need to put mortar in between those two courses there, right? So that would have given you whatever dimension you had plus an additional 460 millimeters. That's 230 that side, 230 on that side. Similarly, whatever dimension you add here, then you would have still had to add 230, 230 on either side. Okay, then fairly straightforward. They wanted the first. Okay, I'm just going to go through the basically what the items that were the thing. First one, they wanted 19 millimeter and 19 MPa concrete to your foundation, and this is how you would have worked out the foundation. Fairly straightforward. Let me bring up the drawing again. I think, okay. Wait, what I must do is, because let me just get the composite drawing. Sorry, class. That would be much easier, because now I must switch between. If not, I must switch each time between. My apologies. 1 second. Let me just bring up the drawing with both. I'll just compose both together, because if not, I'm going to have to switch between this and that all the time. Okay. Right, okay, this is a better document because the whole thing is together. I got it. Right, so as I said, the first item was 19 MPa concrete to foundation, and they tell you here, if you look at it, they tell you that the foundation, it's a strip foundation to the perimeter walls. So it's 600 millimeter wide by 900 millimeter deep. So basically, you would have went and said, first of all, work out the perimeter. The perimeter was fairly straightforward. It's 2 times that dimension plus 2 times that dimension, because you got 1 there, 1 that side, same there and there. So it's 2 times the length plus the breadth. That would have given us the perimeter times your 0.6, which is wide, 600 wide, times 0.9. That would have given you the volume of concrete that you need for your foundation. Okay, fairly straightforward. Then for the next item that they wanted was face brick to perimeter wall. And let's look at the next one. Okay, DPM and cement brick. Right, face brick to perimeter wall. Oh God, that was fairly straightforward. All you had to do was, they told you that the ceiling height was 2.5 meters and you had a gable of 1.2. Obviously, the gable would have went on that, the upper and the lower walls, because that's the shorter dimension. And you'll notice that it's fairly straightforward here again. So it would have been 2 times this dimension that you got, the length, and then plus 2 times the breadth times your 2.5 meters I, to give us the area of the wall along the ceiling height. Then you would have had to add the gable. gable you would have had, basically gable is half base times height, we told you. So which should have been that dimension, which is the, I'm just going to call it, because it varies for each one of us, I'm going to call that side, which is the longer side, the length, and we'll call that the breadth. So it would have been half the breadth times the height, which means half of that dimension times the height, which was 1.2. And I got 2 of those. So times 2. So the halves would have actually cancelled off. So it would have just been the breadth times the height. That would have given us the gable. Then once you got that, you got to take away for your openings. Openings were fairly straightforward. We had 2 windows, which was 2 by 1600 by 1.2 meter high. That's the 2 windows there and there. Then you had 1 door that was 900 and you had 1 door that was 1.5. So it's 900 times 2.1 and 1.5 times 2.1 as well. So that's 0.9 times 2.1, 1.5 times 2.1. You'll take away all of those from the area, and the total area that you got would have been your area of brickwork excluding your openings, right? And then all you had to do was multiply that by 55 bricks per square meter, and that would have given you the brickwork. But unfortunately, I can't do the thing, because remember, each one of you had different answers. That's why I'm explaining what is the methodology, and you can always go through it if you didn't do it that way, right? Then the next item was your DPM. DPM fairly straightforward. You would have used the total length times the total breadth, right? That you calculate. I said we take the total length times the total breadth just to allow for that little bit of wastage, right? That would have given us in square meters. Then cement bricks, all you had to do was the same value. I told you use the same thing for cement bricks. There were no internal walls here. You didn't have to calculate anything. It would have been the same value for the cement bricks. Then your next item was it the lintels? I can't remember offhand. Let's look at the next couple of items. Okay, that was lintels, then the brick force. Right, let's do that. Lintels fairly straightforward. Now you'll need 2 lintels in each of these cases, because they told you it's a double skin wall. It's got an inner and outer skin. So you'll need, so in actual fact, you're going to need 4 over the windows, 2 there and 2 there. So which gives us 4 times your 1600, in brackets, you can say 1600 plus 300 plus 300, which gives me 2.2 meters. So it's 4 times 2.2 meters you're going to need for the windows, 4 times 2.2. And then for the door, you're going to need 2 by 1500 for here, because it's 900 plus 300 plus 300. So you're going to need 2 by 1500 there. And for here, you're going to need 2.1, because it's 1500 by plus 300 plus 300, 2 by 2.1. Now that came to 16 meters exactly, right? And all of you should have had the same answer, because that didn't affect your dimensions or anything, right? That came to 16 meters exactly. Then the next item, they said brick force. Brick force was at every 3 courses. At every 3 courses. So what you would have done is you would have taken the brick force first of all, and you would have, I told you would have first of all worked out brick force for the perimeter. Along the perimeter, you can work out the brick force. And if you work out to ceiling height, to get the number of courses was fairly straightforward. You would have taken your ceiling height, which is 2.5 meters. And for every 3 courses, you'll notice that it comes to 0.255 millimeters, because it's 3 by 85 millimeters each. It comes to 0.255. So that's for every 3 courses, right? So I would have went and said 2.5, and we're going to divide that by 0.255, and you'll notice that that comes to, sorry, what am I saying? Something. Oh, okay. So basically 9.8 courses there. And I told you in class, when you got 9.8, it's actually 9, because you're not going to put 1 on the top there. So 9 plus the 1 that you got at the bottom. In other words, you need 1 right on when you from your floor going up. So that would have actually been 10 courses really. You would have had 10 courses along the perimeter up to ceiling height, and then you would have had to work out at the gable. At the gable, you add basically gable 1.2i. Now the gable, the easiest way is very quickly just to draw a triangle. You draw a triangle and you'll work it with similar triangles like the way that I did it in class. You know similar triangles from your mathematics that you did. That is the easiest way. So in other words, every 3 courses, again 0.255, and you're going to work similar triangles to get. So if you worked out the first one, the dimension was, I'm just saying for argument's sake, let's say 10 meters, then you know by similar triangles you can get every 3 courses. When you go 0.2255, you can work out what, and then you add that to the total perimeter brick force, and then you take away for the openings, right? For each opening. So the doors, you'll notice that the doors, now what the easiest way to do is add both the doors, 1.5 meter wide and 900 millimeter wide. So that would have given us 2.4 meters if you add the 2, right? The openings 2.4 because the door is the same height, 2.1. So I'm going to work out how many courses I'm going to get under the door. It's 2.1 divided by 0.255. You notice that at the door I'm going to take away 8 courses. It's 8.2. I told you always bring it down. So 8 courses I'm going to take away. Remember, yeah, I don't have to add that 1 because basically I'm going to take away 8 courses on that. So that's going to give me 8 times for my door, which was, I said 2.4 meters because I'm adding both the doors one time, same thing. So actually for the doors itself, I would have had to take away 19 meters of 19.2 to be exact, but let's just work on 19 meters of brick force for the doors. And then the windows, same story. I'm going to add the 2 windows, the same height they are. So 1.6 is 3.2 meters, and it was 1.2 meters high. So I'm going to say 1.2 divided by 0.255, which gives me actually 4 courses. So it's 4 times 3.2, 4 times 3.2. So that gives me another 12.8 plus 19.2. That came to exactly 32 meters of brick force that I would have had to minus from the total. Okay, and then that's how you would have calculated the total brick force for there. There are no internal walls. Only one. Sorry.
Did we add brick force to the gable also?
Yeah, I told you. Yeah, I told you. You would have worked out. The easiest way to work out for the gable is by similar triangles.
Okay. Okay.
Right. You have to add for the gable. The only time you don't add for the gable is internal walls, because internal walls don't go up to the gable. They go up to the ceiling height. Okay. But external walls you have to add for your perimeter walls you have to add for the gable, right? Okay. Then the next item. Now this was fairly straightforward. This was actually marked for jam there because the arcs you plaster to perimeter, and if you look at the spec told you that the plaster was going to be 20 millimeters thick, 0.02. All you had to do was take the area that you worked out for your brickwork, excluding all your openings, and you multiply that by 0.02. That's all you needed to do, because for your reveals, in other words, normally you know where you got your openings, your doors and so on, you plaster on the inside of that, the reveals, but that would have been accommodated by the fact that you're taking the entire dimension. That's why I said you take the entire dimension for your wastage, right? So that would have accommodated for the reveals in your windows and your doors. So if you just went and said plaster, you just took the total area of your brickwork, in other words, excluding all the openings. You can't take the opening now. You take away the openings and you multiply that by 0.02. That would have given you the volume of your plaster that's required, right? So that was fairly straightforward. As I said, there was nothing for you. All you had to do was take the final area that you came for your brickwork, either for same thing, because for face brick, or if you use the area on your cement brick. In any case, you would have used the cement brick as the same number of the face brick, but exactly the same thing, and you would have just worked out the volume of plaster required. However, the next part, I think that's where a lot of you, okay, the cement wasn't bad. Cement required for items, both your foundation and your perimeter plaster, was you had to take out whatever you got for your plaster plus whatever you got for your foundations. All you do is that would have given you cubic meters. You multiplied it by 12 pockets, and that would have given us our total number of bags. However, the next part now, where they ask you for how much of sand you're going to need for the plaster, because remember, plastering sand is different. Plastering sand is a very fine sand, and for your foundations, you use the Amghani sand, which is a rough sand, right? The gauge on your sand is different so that you can get different bondings in terms of what you're going to use it for. So the plastering sand, basically, whatever you would have calculated, let's say for argument's sake, you came up to, I'm just using an arbitrary figure. Let's say we came up with 1.2 cubic meters for our quantity of plaster. If you came up with 1.2 cubic meters for quantity of plaster, now these are the last three items that I'm looking at, basically looking at plastering sand, how much you needed, Amghani, how much you needed, and how much of stone you needed, all in cubic meters, right? But there we go. It tells you that for your sands, you needed 12 bags of cement to 1 cubic meter of your sand, plastering sand, right? Now, one bag of cement, I honestly expected you to have known that, considering that you did materials and so on, methods and so on, but seemed like a lot of you didn't know that. I think that this only a handful of you answered this part of it. Besides, most of you left it. This I'm talking about answered and that got it right. It's just a handful of you, right? So what you needed to do here was basically for every 1 cubic meter of sand, you're going to have 12 bags of cement. Now, 1 bag of cement is actually 0.0347 cubic meters. Now, surely you would have known that, right? 0.0347 cubic meters. So in other words, for every 1 cubic meter of sand, it's going to be the 1 cubic meter of sand plus 12 times 0.0347 cubic meters of your. Because remember, the cement you're adding is also adding to the cubic meterage, yeah? 12 times 0.0347. So you'll notice that for every 1 cubic meter of sand, you actually got 0.42 cubic meters of cement for the plastering. For every 1 cubic meter of sand, you got 0.42. So that's why whatever value you got, so in other words, the 1 cubic meter of sand plus the 0.42 cubic meters of the cement means that for every 1 cubic meter of sand that you're mixing, your actual volume is going to be 1.42 cubic meters. Do you all agree? You all understand the concept? So what I'm saying, for every cubic meter of sand, you're going to get 1.42 cubic meters in total when you add your cement. So whatever value you got for your plaster, let's say I said, if for argument's sake, if you came up with 1.2 cubic meters of plaster that you require total, the amount of sand will be 1.24 divided by 1.2. I said, if let's say you had 1.2 cubic meters of plaster that you required, so it'll be 1.2 divided by 1.42, which means that if you look at it, the sand itself is 0.85 cubic meters. So 0.85 cubic meters, and the rest of it, which would have been 0.35, would have been made up of the cement, the 12 bags of cement. Right, so please just remember that is the ratio. Don't ever forget. That should be a golden number that you should remember. There's 2 numbers that I still remember when I was studying. Is 1, the conversion from feet to meters. Anyone knows the conversion offhand? From feet to meters. Anyone? From feet to meter, I will never forget that value, because those days when I studied, we never had calculators and so on like you. We used to use what we call 12-figure log tables, 15-figure log tables, find out values there. And the conversion factor, I hope you remember this, is 0.304757269.4. That is a conversion. Now that's how we remembered it, because we needed to work on a log figure table that was normally, the average one was about 9 figures that you needed to work off. And same thing, and the other thing was a pocket of, because cement comes standard 50 kgs from the time I remember. I think when I was a little boy, it always came 50 kgs. And 1 pocket of cement is 0.0347 cubic meters. Those are the 2 magic numbers that you should remember, every student doing civil engineering. Right, now, there we go. So I said, if you took the volume of plaster that you, total volume of plaster you require. I said, let's say for argument's sake, you need 1.2 cubic meters. You divide it by 1.42. That is the magic value if you working conversion for, if you want to work out how much sand only. That means that you want to use 0.85 cubic meters of sand and 0.35 cubic meters of cement to get 1.2 cubic meters. Similarly, when you worked out for your Amghani and your stone, now in this instance, the Amghani and the stone is, well, normally 99.9% of the time, you'll notice that you use the same quantity. Sometimes you'll notice that you'll get bigger stone, 19 millimeter, you can get 37 millimeter stone, but the size of the stone might vary, but generally, normally you'll notice when guys are mixing, they'll say, okay, 12 barrels of sand, 12 barrels of stone to 4 pockets of cement or whatever. You'll notice the sand and the stone is normally equivalent. Right, so that's why you'll know whatever quantity you got, half of it would have been cement, half of it would have been Amghani sand, half of it would have been stone, and the rest of it would have been the cement. So same story here now, whatever you got, let's say, I'm just saying for argument's sake, let's say for our foundations, we calculated to do it to come to 18 cubic meters. So you'll get 18 divided by 1.42. That means that the sand and the stone itself is only going to be 12.7 cubic meters. 12.7 cubic meters of sand and stone to give us 18 cubic meters final mix. That's what we're talking. The rest of it would have been the cement. So to work out how much sand, how much stone, 12.7 divided by 2, which means 6.35 cubic meters of Amghani sand, 6.35 cubic meters of stone you would have required. That's how it was, fairly straightforward. In fact, because so many of you didn't answer that question properly, I had to reduce the marks down. Initially, that was carrying, I think, 4 marks each. I had to reduce it and add marks like for your brickwork, and also that I can just make sure that you guys, some of you can see through with the mark that's required, because I think most of you didn't answer that, and I had to reduce the marks on that down to, I think, two marks for the quantity of your plaster, 2 marks for this. So in other words, 2, 1, 1. I split the other one into 1, 1. I think cement and for your Amghani sand and your stone. Any questions, class? That's basically what you have to do. Fairly straightforward. Any questions, class?
So for the tutorial, we didn't use Brickwork in the gables.
Sorry?
That's why I was asking. We didn't use the Brickwork in the gables.
You didn't use it?
Yeah, in the exercise before the exam.
We did. You have to put Brickwork on the gable.
No, it wasn't in the tutorial. That's why I was asking again.
No. I would have mentioned it, but I don't know. Maybe it was wrong in the calculation. Is that what you're saying? You have to.
Yeah, from the calculation, it's not.
Yeah, because I remember clearly. I told you about the gable that you'll have to. Basically, it's a triangle, so you have to work out what. Because I left you to finish the tutorial. You remember?
Yeah, I know, sir.
Yeah. You have to use it. You have to take the gable. Gable, you must put Brickwork on the gable as well. Okay.
Okay, thank you.
But just remember, just remember that basically the procedure is exactly the same, whether I gave you a building or if I gave you, let's say, a chamber to do. It's exactly when you work out, you take the outer dimensions and you work out everything, because the little extra you don't have to worry about. Some would argue that, okay, the breadth wall is slightly shorter. That's accommodated for our wastage and so on. Okay. Any other questions, class? I'm done with your marking. Hopefully by, let's say, by tomorrow. What's tomorrow? Thursday. By Friday, latest. I'm hoping by tomorrow I should have finished capturing everything and sorted everything out. Okay. So I'm saying latest by Friday, your mark should be on the portal. On the overall, yes, the class didn't do bad at all, but obviously there's some of you that don't understand what's going on whatsoever. Sorry, class. Is there any other question? I just want to take this PMB. Just 1 second. 1 second. Hello? No, not too bad. And yourself, Della? Yeah. No, shame. Yeah. Everything is set. Like, I did. It's the same link. You haven't changed anything. Yeah. But what I'm saying, the link will be the same. Okay. No. Okay. I'll just go through it and just check it out. No problem. Thanks, Daryl. I'll let you know. No problem. Thanks, Daryl. Right. Cheers. Right. Bye. Sorry about that, class. Yeah. Sorry. That's a co-lecturer from Maritzburg. Any questions, class? Class, any question? I presume there's no other questions. Okay, class. What I suggest now that I've explained to you what's actually needed to be done and so on, I think as part of your tutorial, I would strongly recommend you to go through that again. Right, just go through it, especially if you think that you didn't do it like the way that I've explained now. I strongly suggest, especially the items that you think you would have messed up. If you, for example, I think the lintels, I think most of you answered that. That I didn't find a problem with that. So maybe there's no need for you to do the same, but the rest of it you need to go through and just check where you went off. Okay. Thank you. Not all of you, but obviously you know if you didn't do it the way that I explained. Okay. Thank you very much, class. Is that, if you don't have no questions, then yeah, you can just go through that tutorial and just finish it as your test tutorial. Okay. No questions? All right. Thank you. Bye.